Hello everyone. Today our group is going to present the mini project of the fluid mechanics, which is series of pipeline system. I'm Jai. I'm going to introduce about the three main classes of the pipeline system. So first of all is the class 1. So the system is completely defined in the terms of size of the pipes, types of minor losses, and the volume flow rate of fluid in the system. So for the class 1 is to compute the total head on the pump, the elevation of the source of fluid to produce a desired flow rate of pressure at selected point in the system. So for the class 2 in the pipeline system is to determine the volume of flow rate of fluid that could be delivered by a given system. So the system is completely defined in the terms of size of the pipes, elevation, valve and fittings, allowable pressure drop in the system. While for the class 3 in pipeline system is the general layout of the system is known along with the desired volume of flow rate, and the size of the pipe is required to carry a given volume flow rate of a given fluid is to be determined. In the real world, there are many types of pipeline systems such as tank, valve, or even a gas pipeline network. In this mini project, we are focusing on the class 2 pipe in the petrol tank. So I would like to pass the other part to my group mate, which is Li Chen, to continue.
So, here we're gonna show how to calculate the series pipeline system for class 2. From this diagram, we can get the value of Q2 equal to 250 gallon per minute. Temperature for ethyl alcohol is 77 degrees Fahrenheit, and the total length of the pipe is 110 feet. We want to find P1, which is the pressure in tank A. First, write down the general energy equation and then rearrange it to get P1. After that, calculate V2 by using formula V2 equal to Q over A. The value of Q is 250 gallon per minute, and the value of A is 0.02333 feet squared. The value of A can get from schedule 40 for 2-inch pipe size. Then the answer is converted into feet per second. Then calculate V2 squared over 2G. Substitute the V2 we get just now and use 32.3 feet per second squared to get the answer in feet. Next, we find the value for Reynolds number by using formula. The value of inside diameter D can get from appendix F, while the value for density of ethyl alcohol and dynamic viscosity of ethyl alcohol can get from appendix B. Since Reynolds number is greater than 2000, so it means the flow is turbulent. After that, we need to calculate the relative roughness by substitute the value for the inside diameter and roughness of the pipe. Now, we can find the friction factor F from the Moody diagram based on the value of Reynolds number and relative roughness that we calculate just now, which is F equal to 0.0205. Then we calculate the loss of the pipe, which is the summation of H1, H2, H3, and H4. In this case, we use Ft equal to 0.019. While H1 represents the entrance, H2 represents the valve, H3 represents the elbow, and H4 represents the friction. Then, sum up the H1, H2, H3 and H4 to get the final answer for head loss. Now, we have found all the value needed in the general energy equation. So, substitute all the value found to get the pressure in tank A, which is P1. That's all for today. Thank you.